we're going to go over is the completing the square to turn it into vertex form. When we complete the square, what's the very first thing we do? Take the 17, move it over to the other side. Y minus 17 equals x squared minus 8x. Leave a blank. Divide the 8 by 2. Now it's not an 8 though. What is it? Negative 8. Okay, so negative 8 divided by 2 is negative 4. And then what do we do with the negative 4? Square it. Negative 4 multiplied by itself, 16. So I'm going to put the 16 in the blank on the right side, but I can't just add a 16 to the right side. I have to add it to the left side as well to keep the equation balanced. Okay, so here's my equal sign. Parentheses x minus 4 squared. So whatever I got when I divided by 2, that's always what goes in the parentheses. So I got a negative 4, x minus 4 squared. And then what am I going to have over here? Negative 1. So I got y minus 1. Okay? Now what do? I add the 1 over here so I can get my y all alone. So I've got y equals x minus 4 squared plus 1. So I've done the completing the square process, and I got this into vertex form. And if somebody wanted to know the vertex, they could tell me. What is the vertex? 4, 1. Yeah. So if I wanted to know what it was, I could say. All right. Okay, factoring. Can we tell what type of factoring this is? Say it again. The regular kind? What is the regular kind? It's 3 letters. What are the 3 letters? GCF, greatest common factor. So I'm going to grab my calculator. I'm going to hit the math button. I'm going to go over to number. And then which option am I going to use? 9. And I'm going to type in 15, 12 to see what the GCF is between 15 and 12. 3. So I can take a 3 out. 15 and 12 both have a 3 in there. And then between an x squared, and this would be an x to the 1. They didn't write the 1, but it's there. It's just invisible. How many x's do I get to take out? 2 or 1? 1. I get to take out 1. I always take out the smaller number. So in my parentheses, I'm going to have 2 things. 15 divided by 3 is 5. I had 2 x's. I took 1 out. So how many are left over? Just 1 x, okay. 12 divided by 3, 4. I had 1 x, I took it out, so I don't need an x. Is there any part of that that needs to be re-explained? Any part of that that didn't make sense? We're good? All of that made sense? Okay. This one is a trinomial. What are we doing with the trinomials? The 3 pieces. What do we do with these ones? We make the x thing. We multiply to something and we add to something. Multiplies to 24. Adds to negative 10. Okay, so I'm going to grab my calculator. I'm going to hit the y equals button. And what am I going to type in here? Anyone remember what I type in there? 24 divided by x. Okay, 24 divided by x. And then where do I go from there? Second graph. Okay, now all of these options multiply to 24, and I need to figure out which one adds to a negative 10. These are all positive, so I don't want to do positives to add to a negative 10, so I'm going to go the other direction. So negative 1 and negative 24 does not add to negative 10. Okay. Okay, negative 4, negative 6. And then what do we do with the numbers once we've found them? Put parentheses. What do we write in the parentheses? X minus 4, x minus 6. Okay. We're going to take notes first. Then you can go. All right. We good with the warm-up? Our brains are like, oh yeah, that's what we did last week. We're starting to come back. Okay, we're going to take some paper out for notes. So go ahead and put your warm-up off to the side. And we are going to be factoring trinomials and we're going to use the method today called slide divide. Slide divide. Some people just call it slide divide. Some people call it slide divide bottoms up. It's the same thing. Slide divide. So trinomials, what does tri mean? 3. So we're dealing with 3 nomials today. Now, these are going to be just a little bit more difficult than the ones that we did on Friday. And I'm going to show you, I've got the notes from Friday. So I'm going to kind of compare these ones with the ones that we had from Friday and show you how they're a little bit different. So I'm going to write down our first example because we want to know what is going to make it so you have to do it the slide divide way, which is a little bit more complicated, and when you can do it the way that we did it on the warm-up today, the way that we did it on Friday. So here's this problem. Looks very similar to the warm-up. If we look back at our notes from Friday, I'm just going to show you the notes from Friday. On Friday, this was the first problem we did, and we said, okay, x squared plus 14x plus 45. We looked for what multiplied to a 45 and added to a 14. Got the numbers, we were done. C squared plus 2c minus 48. We looked for what multiplied to a negative 48 and added to 2. Easy. What multiplied to a 26 and added to a negative 15 here. So this was the problem that we had. When we started to get a little bit more complicated down here, we added a number in the front. And we saw that the number in the front was a GCF. So the extra step was to take the GCF out first. And then we saw k squared minus 8k minus 20. So we looked for two numbers that multiplied to negative 20 but added to negative 8. And then our final answer just had that GCF in the front. This one had a GCF as well. So we took the GCF out, and then we were looking for numbers that multiplied to 6 and added to negative 5. So let's compare that. This is from Friday. Let's compare that with the one that we're doing now. It's got a number in the front, but the number in the front is not a GCF. You guys see the difference? So with what we were doing on Friday, the ones that were easy, they either started where x squared or c squared or w squared, it was all by itself to start with. That makes them easy problems. Or if they had a number in the front, like 2k squared, 5z squared, or this one was a negative x squared, or if they had something in the front, you could take it out. Those were the ones we did on Friday. The difference with today is we're going to have a number in the front, and you're not going to be able to take it out. You're going to have to do the problem with the number in the front, staying in the front for the whole problem. Does that make sense? That's the difference about today. So when you're doing these problems, if the number in the front is not a GCF and it sticks around, the method that you're going to use is slide divide. Okay? So the very first step that we do is we slide the 2 over to the 18 and we multiply those numbers together. So what is 2 multiplied by 18? 36. So we're going to draw the x just like we did on Friday, and we're going to say 2 times 18 is 36. So we are looking for two numbers that multiply to 36 and add to negative 15. So it's kind of similar to what we did, but it's slightly different because we had to slide a number to get what we're multiplying to. All right, so now I'm going to grab my calculator. And I'm going to say I'm looking for two numbers that multiply to 36 and add to negative 15. And does anyone know what those numbers are? Negative 3 and negative 12. Okay. So what I do next is I take those numbers, I put them in the parentheses. So I'm going to write x minus 3, x minus 12, but I'm not done yet. So first I took the 2 and I slid it over to the 18. So that's the slide part. Next I'm going to do the divide part. I'm going to take the 2, since I slid by 2, now I'm going to divide by 2. I slid the 2, now I divide by 2. And what you'll notice is that when you divide by 2, you end up getting these fractions. Sometimes the fraction can reduce, sometimes the fraction cannot reduce. So over here we have a 3 divided by 2. That fraction does not reduce. 3 over by 2 is the smallest fraction you can have. But over here we have a 12 over 2. What is 12 over 2 is 6, so I'm going to write x minus 6, okay? And then if the fraction is reduced enough already, when you're done reducing it, you take the bottom of the fraction and you bottoms up. You bring the bottom up to the front of the x, and you write 2x minus 3. And that is the end of the problem. So some people call this slide divide. Some people call this slide divide bottoms up. So you can call it whatever you want. Slide divide or slide divide bottoms up. Whatever you want to call it is fine. Okay, let's try another one. 12x squared plus 5x minus 2. Okay, so the first thing we're going to do is we're going to take the 12 and we're going to slide it over to the negative 2. So 12 multiplied by negative 2 is what? Negative 24. So we are looking for two numbers that multiply to negative 24 and add to 5. Multiply to negative 24 and add to 5. Six and negative 4 would add to 2. 8 and negative 3. Okay. 8 and negative 3. Okay. So we're going to have x plus 8, x minus 3. The number that we slid over was 12, so now we have to divide by 12 and divide by 12. And this is an interesting problem because both of those fractions reduce. Both of those fractions reduce. So 8 over 12. Yeah, what number divides out of 8 and 12? 4. So if we take 8 and divide it by 4, what's 8 divided by 4? 2. What's 12 divided by 4? 3. Okay. And then over here, what do 3 and 12 both divide by? 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. Okay. So we reduced both of the fractions. They are still fractions. So now that we have two fractions that are still fractions, now we can bottoms up. So I'm going to take both of the bottoms and move them up in front of the x's. So I'm going to have 3x plus 2, 4x minus 1. Yep. And sometimes when you first write the fraction, it'll be as reduced as it can be, and sometimes you have to do more work to get there. Okay, let's do 6y squared minus 5y minus 21. Okay, what do we do first? Multiply. So 6 times the negative 21 negative 126. So we are multiplying to negative 126 and adding to negative 5. Multiplying to negative 126 and adding to negative 5. Negative 14 and 9. So I'm going to say y minus 14, y plus 9. And then what number do I divide by? I divide by 6. So 6 was the number that I slid. That means that 6 is the number I divide by. Now, neither of those fractions get to divide evenly, but they can both be reduced. So this one can, both the top and the bottom can divide by what number? 2. They both can divide by 2. So y minus 14 divided by 2 is 7. 6 divided by 2 is 3. 9 over 6, what can both of those numbers divide by? 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Okay, so we've reduced both of the fractions, and when we reduce them, what do? We bottoms up. So 3y minus 7, 2y plus 3. How do you guys feel about those? I want to give you guys one that has a GCF in it. How do you guys feel about me giving you one with a GCF in it? Okay, let's do this one. We're going to do 16m squared plus 60m minus 54. So we always, if there's a GCF, we always want to take that out before we use another method of factoring. Because other methods of factoring are always going to be easier to do with smaller numbers. But also, sometimes the GCF messes up the other methods of factoring. So I know there's a GCF in this problem. Can anybody tell me how I might know that there's a GCF in this problem? Say it again. Because I'm a math teacher. I know there's a GCF in this problem. I will tell you I don't know what the GCF is, but I can tell there's a GCF in the math problem. Anyone know how I can tell?
They're all even?
They're all even. I saw that all of these numbers were even numbers, and as soon as I saw that, I was like, well, they can at least divide by 2. I don't know if the GCF is 2, but they can all at least divide by 2. So I at least know that there's a GCF of 2, but it might be bigger than that. Does that make sense? So I can at least see that happening. So if you guys remember, when we do the GCF, we can only do 2 at a time on our calculator, so we can't do all 3 of these. But we can kind of check around and do the different combinations to see what they are, and then kind of make a guess and then see what number goes into all 3 of them. Question? Biggest one. Yeah, should be the biggest number that goes into all 3. 6, we think 6 might be it. Okay, so I know if I look at 60 and 54, I'm pretty sure that 6 is the GCF of 60 and 54. Yeah, but does 6 go into 16? It doesn't go into 16. What if I do 16 and 60 and just see what number is the biggest that goes into those? 4? Does 4 go into 54?
Yeah.
16, 54, 2. So maybe 2 is it. Maybe 2 is the only thing that goes into all of them. Yeah? Okay, let's take out a 2. So if we divide out a 2 from the first piece, what is left over? 8 m squared, okay. If we divide out a 2 from the second piece, what's left over? 30m, okay. If we divide out a 2 from the third piece, what's left over? 27, perfect, okay. And then from here I can see, like, yeah, I can't take anything else out. So these have a 3 in common, but the 8 doesn't. And then the 8's got like a 2 and a 4, and there's nothing from here. I don't think I can do anything. So at this point, I'm going to kind of ignore the 2. I know that when I get to my final answer, I'm going to have like a GCF of 2 and then 2 sets of parentheses like this. I know that's what my final answer is going to look like, but I have some work to do before I can get there. So let's do the 8 and slide it over to the negative 27. Negative 216? Okay. Yep, negative 216. So we're going to multiply to negative 216 and add to 30. Negative 6 and 36. Okay, so we have m minus 6, m plus 36. I'm going to keep that 2 in the front. Okay. So we have our parentheses, and then what should we do? Divide by, what number did we slide? We slid an 8, so we always divide by the number that we slid, not necessarily what number's in front. So the number we slid was an 8, so I'm going to divide by an 8. And now we have to reduce those fractions. So if I have a 6 over an 8, what number can I divide out of the top and the bottom? 2. So if I take the top and divide it by 2, and if I take the bottom and divide it by 2, 4, okay. And then over here, 36 over 8, what can the top and the bottom be divided by?
8.
The bottom can be divided by 8, but does 8 go into 36? 4 does? 5? 4 goes into 36, 4 goes into 8. So 36 divided by 4 is 9. 8 divided by 4 is 2. Okay. So now we have reduced both of our fractions. So all we have to do now is just bottoms up. So what are the parentheses?
4m minus 3. And 2m plus 9.
Okay. Okay. How do we feel about that? All right, I'm going to hand out a worksheet. We're going to start just doing the front side, and we'll see how far we get. I don't think the front side has any GCF problems on it, but I do see one problem we probably want to do together because the numbers are really big. Okay, so we're going to start on the front side of this page, and we're going to do number 9 together because the numbers are very large. usually do number 9 because the numbers are big. Okay, let's do number 9. Okay, so if we look at number 9, I'm going to see if those numbers have anything in common, like if there's a GCF, but I don't think there is, because I don't think this worksheet has any GCFs on it. 35 and 59, 1. Okay, so no GCF. So this is not a GCF problem. Okay, so if we start off number 9, we're going to slide the 35 over to the 48. So we're multiplying to negative 1,680 and we're adding to negative 59. Thank goodness we do calculator tricks and don't use our brain for these. Okay, so we're multiplying to this. And adding to negative 59. So that adds up to something in the thousands. Hundreds, 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 hundreds. Decimal. That adds up to the hundreds. Still over 100 there. That's like negative in the 90s. 20 and negative 84, that's negative 64, so we're getting pretty close here. Can somebody check and see what this is? I think this might be it. What is negative 80 plus 21?
60.
Wait. Negative 59. So these are our numbers. Okay, so 21 and negative 80. 21 and negative 80 are the two numbers, okay? So in our parentheses, we have x plus 21, x minus 80, okay? And then what do we do? Divide by 35. How did we know that it was 35 we were dividing by? That was the number we slid. Okay, divide by 35. Divide by 35. Okay. We have to reduce those fractions. Is there a number on the top and the bottom? 21 and 35. Is there a number on the top and the bottom we can divide out? 7? Uh-huh. So 21 divided by 7 is 3. 35 divided by 7 is 5. Okay. Is there a number that we can divide out of 80 and also divide out of 35? 5. Okay. What's 80 divided by 5? Might need your calculator. 16. What's 35 divided by 5? 7. Okay. And then we'll go ahead and we'll bottoms up. So our first set of parentheses is 5x plus 3, and our second set is 7x minus 16. And remember, these parentheses can be backwards, so they can go this way, but they can also go the other way. What letter does this correspond to? H. Okay, so number 9 is H. Okay. That one was definitely the hardest one on this page. So for right now, we're going to start with the front side of the worksheet, and then depending on how quickly we work through the front side, we might do the back, but we might not do the back. Okay? So at least do the front side. Sound good? We can do that? All right.